Hello. In this video we're going to be discussing the intermediate value theorem. And the intermediate value theorem is written here. Suppose that our function f is continuous on some closed interval from a to b inclusive, and let n be any number between f of a and f of b. Then there exists a number c in our interval ab such that f of c equals n. Now I have the first quadrant of a coordinate plane drawn here, and I'm going to use that to kind of illustrate the point that's being made by the intermediate value theorem. So let me draw some sort of function here, and there it is. And so we begin and end right there. Notice I have closed circles. And so we'll call this right here an x value of a, and this is an x value of b. And so our interval is closed or continuous between a and b. Now up here then, on our y-axis, this is our value f of a, and up here this is our value f of b. F of b. There we go. So that's the setup of this. What the intermediate value theorem is saying is that we're going to have some number n, and I'll say that n is sitting right here, because it has to be between f of a and f of b. And if I were to draw over, I'm going to hit a height somewhere on this portion of the continuous function. And so because we hit n, there has to be some sort of value down here that we called c, where that if we plugged in f of c, if we did f of our x value, the result would be the y value of n. Intuitively, this might make sense, because if we start at f of a and build up to f of b, and we know that n is in between those two numbers, eventually it's going to have to go through n to get from f of a to f of b. And in the same case, if we know we're going from a to b, at some point it's going to have to pass through c in order to get from a to b. So let's put this to use. We're going to use the intermediate value theorem to show that there is a root for this equation here, 4x cubed minus 6x squared plus 3x minus 2 equals 0. We're going to show that the root exists, or there is a root somewhere between 1 and 2. It may not be the only one, but we can show that such one exists. So what I'm going to do is I'm going to let f of x equal, we'll do 4x cubed minus 6x squared plus 3x equals 2. So that's my function. I just copied what was above. So for this to be a root, what we need is for some number c such that we do f of c. So we're going to plug some number c in for x, and the result needs to be 0. So considering my interval here of from 1 to 2, my function is a polynomial function. So I know that it's continuous everywhere. And so it will definitely be continuous on the interval from 1 to 2. And I need to find some value c that is between 1 and 2, not including the numbers 1 and 2. And that should result in an n value of 0. So I'm going to do f of 1, and we'll see what we come up with. So that's 4 times 1 cubed minus 6 times 1 squared plus 3 times 1 minus 2. 1 cubed is 1 times 4 is 4. 1 squared is 1 times negative 6 is minus 6. Plus 3 minus 2. And we get the result of negative 1. Now I'll also plug in f of 2. And so we'll see what we come up with here. So 4 times 2 cubed minus 6 times 2 squared plus 3 times 2 minus 2. 2 cubed is 8 times 4 is 32. 2 squared is 4 times negative 6 is minus 24. 3 times 2 is 6, and then minus 2. And so when we total all that up, we get a value of 12. So what we just showed is that our value n, which was 0, sits somewhere between f of 1 and f of 2. F of 1 being less than 0, and f of 2 being greater than 0. So by the intermediate value theorem, then we must have some sort of c that makes f of c equal to 0. And I'll just shore this up by writing this down. So by the intermediate value theorem, there is a number c, such that f of c equals 0. Now if I sort of tried to sketch this, here's my coordinate plane, here's where x is 1, here's where x is 2, and I have a y value of negative 1, and a y value of 12. So we would have the ordered pair 1 comma negative 1, and an ordered pair 2 comma 12. So whatever happens in between those 2 points, at some point it has to cross the x-axis to give us a y value of 0. And so if it looks like that, whatever, I mean, that's fine. But right there is going to be my c value that shows that we definitely have to cross the axis and give us a root. And we are done.